Hello, hello, hello. Here we are with our 4B notes. So we're talking about regression and modeling. So we've been giving you word problems with specific information, and you have to decide if it's exponential growth or decay and write the function based on the information given. Well, what if we don't give you a word problem, but what if we just give you a set of data and you have to decide if it's exponential or not, and then let your calculator come up with the model for that exponential or whatever kind of data it is, their model for that. So how do we find the best model for a set of data? So the first thing we need to remember is determining the type of data that we have based on a table or some set of points. So we've done this before with linear and quadratic, so now we'll do it with exponential. Remember here, it says that if your inputs are equally spaced, then you need to look at those y values. If the first differences are constant, then it's linear. So what does that mean? Well, that means if the change in the y values is the same every single time, then that's linear data. And that makes sense, right? It's the same change of value every time that my x's are moving up or down or whatever. Quadratic data obviously is not going to have the same change in the y values over and over again. However, the second set of differences are constant. We've done that before back in our quadratic unit, back in like unit 4, unit 5. Now we've been talking about exponential. Well, exponential data doesn't have the same value of change, but it does have the same ratio of change. Okay, so I'm either multiplying by some number over and over and over again, or I'm dividing by some number over and over and over again. Remember, dividing by a number is just multiplying by the reciprocal. So I could be multiplying by 3 over and over and over again, or maybe I'm multiplying by 1/2 over and over and over again. That's that common ratio that would determine if it's exponential or not. So again, we need to make sure that our inputs are equally spaced. If they're not, then we have a little bit of an extra step to worry about, but for these problems, all of our inputs are equally spaced. If you notice in part A, they're just increasing by 1. In part B, they're increasing by 2. In part C, they're increasing by 10. And then in part D, again, increasing by 2. So that's good news for us, is that our inputs are equally spaced, which means we can now just look at those y values and determine what does the change look like. Is it by a certain value, which would make it linear? Is it by a certain ratio, which would make it exponential? And if it's neither of those, then I would probably check that second set of differences to see if it's quadratic or not. And remember, you always have the possibility that it could be none of the above. So here we have. In part A, I look at my changes in y's, 0.5 to 1, 1 to 2, 2 to 4, 4 to 8, 8 to 16, 16 to 32. I can immediately tell that I'm not increasing by the same value. And because those numbers are pretty easy and they're pretty, it's very identifiable what's happening here. I'm multiplying by 2 every single time. 0.5 times 2 is 1. 1 times 2 is 2. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Times 2 is 32. So there is a common ratio here, which makes this data exponential. Okay. I'm going to go ahead and go down to part C, 15, 12, 9, 6. I notice that I'm subtracting 3, subtracting 3, subtracting 3. Linear. It's changing by the same value every single time, so that's linear. When I go up to part B, 2 to 0, that means I'd be subtracting 2. 0 to 2 would mean I'm adding 2. I'm adding 6. I'm adding 10. I'm adding 14. I'm adding 18. Clearly, I'm not adding the same value every single time. There's no way that I can multiply something to 2 to get 0 and then multiply that same thing to 0 to get 2 and then to get 8 or 18. So there's no common ratio. So now I need to check, what about those second differences? Well, from negative 2 to positive 2, I had to add 4. From 2 to 6, I added 4. Add 4. Add 4. Add 4. So this means that this data is quadratic. So I would always probably check, see if it's linear or exponential first, and then if it's neither of those two, check to see if it's quadratic. It might not be that either, so it could be none or you would see that it's quadratic. And then in part D, 27 to 9 to 3 to 1. I could immediately determine that it's not going to be linear because the values are not the same. I would check exponential first, and I noticed something. I noticed that 27 divided by 3 is 9. 9 divided by 3 is 3. 3 divided by 3 is 1. So I'm dividing by 3 every time. Or another way of saying that is I'm multiplying by 1/3, multiplying by 1/3, multiplying by 1/3, which does give us that common ratio, which means that it is exponential. Okay, so you always want to make sure that your inputs are equally spaced, and then check out the change of your y values. If it's adding or subtracting by the same value, linear. If it's multiplying or dividing by the same number, exponential. And if those second differences are the same, then that's quadratic. Going on to example 2. So now it says we need to use some algebraic methods to write an exponential function in the form of y equals a times b to the x, whose graph passes through the given points. Sounds to me like this is going to be a system of equations. I'm given 2 ordered pairs, so that means I have 2 sets of x and y values, which means I can plug that into that function of y equals ab to the x power, and I can use that system to solve for a and b, and then write in my final answer. So that's exactly what we're going to do. So I'm going to start with my first point of 1, 6, 1 being my x value, 6 being my y value, and I'm going to plug it into this format here, y equals ab to the x. So that would be 6 equals ab to the first power. Okay, I'm going to go ahead and write my second ordered pair in that function format again. 54 is my y value, ab to the x, which in this case was 3. So I have a system and I need to solve for a or b, substitute it into the other function, and solve for the other variable. Well, the easiest thing I see is the first problem. I can rewrite that, solving for a. How would I get a by itself? I would just divide by b. Remember, b to the first power is just b. So that's why I went with the first one and not the second one, because I don't know what b is, so I don't know what b cubed is. But I know b to the first power will always be b, no matter what. So I can just get 6 divided by b. Well, now that I know what a is equal to, I can take that value and substitute it in here, which would then give me 54 equals 6 divided by b times b to the third power. Well, applying our exponent rules, I know that that would really be 6b cubed divided by b. b cubed divided by b is just going to be b squared. So this turns into 54 equals 6b squared. And now I'm just following order of operations to solve for b. Because I'm not simplifying, I'm solving for a variable, I want to work backwards in that PEMDAS. So I want to divide by the 6 first and then take the square root. Dividing by 6 first will give me 9 equaling b squared. Taking the square root will give me just 3. Remember, I want a positive value for b, so I'm not going to apply the positive or the negative of 3 because I don't want my base to be negative. Remember, we talked about that. So b is just going to be 3. So if b is 3, now I can plug it back in to solve for a, which would mean a is equal to 6 divided by 3, so a is 2. So now that I know my a value and my b value, I can put it all together and say y equals a times b, which is 3, raised to the x power. And you can leave it like that, 2 times 3 to the x, or you might see it written in parentheses, 2 times 3 to the x. Whatever you want to write it in, that's totally fine. Just remember, you cannot rewrite that as 6 raised to the x power. Okay, so let's try it again in part B. So the first one would give us 10 equals ab to the 1. Second one would give us 40 equals ab cubed. Same process. I'm going to rewrite that first one into a equals 10 divided by b. And I'm going to plug it in for my a value into the second equation. So now I have 40 equals 10 over b times b cubed, which just simplifies to 10b squared, which is equal to 40. So if I have 40 equaling 10b squared, I divide by 10 first to give me 4, take the square root, so I get b to be 2. So now that I know the value of b, I can plug it back in to my formula here, which is going to give me 5. So a is 5, b is 2. So that means I have y equals a times b raised to the x power. And there you have it, using a system of equations. And then our last part of the notes here, this was a really quick lesson, was using our calculator. Okay, so we've done regression with quadratic data before. Remember, we went to menu and we're going to arrow over to statistics, which is option 2. We're going to enter in all those x values into list 1 and all those y values into list 2. Notice I give you a table here. We're talking about a store that's selling trampolines. So it says the table shows the number of trampolines sold during the Xth year that the store has been open. So X is the years that it's been open and Y is the number of trampolines sold. It tells us in the problem that this is going to be exponential data. It says write an exponential function that models the data. If I give you a table and say write the appropriate model for this data, the first thing you need to do is decide, is this showing linear data, quadratic data, exponential data, etc., etc. You're going to input the table and the data into your calculator just as is. You're going to go to menu and statistics, enter in the x values and the y values. But the second part of this is when you graph it to get that visual, or if you're just jumping straight to telling the calculator what kind of model to go off of, you need to make sure that you're selecting the correct one. This problem told us that it's going to be exponential, so we know we can click on exponential regression. If the data that was provided to us was quadratic, you'd want to make sure that you're selecting the quadratic regression, or if it's linear, etc., etc. That's why I encourage you guys, whenever we did this for quadratic, to get the graph first, which is the second part in our table right here. Okay, so looking at the graph will obviously give you a better idea too of what kind of model it is. If it's having that parabolic shape, quadratic. If it's looking like that exponential parent function, then you'd click on exponential. If it looks like it's linear, then you'd click on linear. Okay, so whenever we plug in these steps with this data, we get a model that says that our A value is 8.46 and our B value is 1.42. So there's the model for this data. The question also asks us though, do you think this model can be used to predict the number of trampolines sold in the 15th year? Well, of course it can. What's representing the years that the store has been open? That's the X value. So all we need to do now is plug in 15 for X. And we can plug that straight into our calculator and we get approximately 1,628 trampolines sold. Okay, so this is showing the regression steps on the Casio. So like I talked about earlier, if you have a Casio at home or if you are using the emulator provided through your software on your iPad, that's totally fine. If you're using a TI, or if you have a TI at home, or if you're doing the TI on the computer, whatever, I did make a list of just the steps to get that regression. Basically, you're going to be going to your stat button, which is kind of towards the top on the right-hand side. To enter in your data, you'll arrow over to edit, or select edit, which is option 1. You'll still enter in those X values into L1 and the Y values into L2. Then you'll go back to stat, arrow over to calculate. And then if you scroll all the way down to option 0, you'll see exponential regression. Again, if you need to choose quadratic regression or linear regression, those options are there for you. Once you click on exponential regression, you'll see that table that'll give you the A value, the B value, etc. You'll click on calculate, and then you'll see this screen right here that says exponential regression is in the form of y equals a times b to the x power. What is my a value? What is my b value? And that's the exact same thing we got here. The a value was 8.46, the b value is 1.42, and so then we can use that model to figure out how many trampolines are sold in whatever year that we need to. All right, talk to you later. Bye.